Okay, we're in the home stretch of our ontology sessions. This is the fourth of 4 regular sessions. There'll be a panel session after the coffee break. We have the pleasure of having Mike Poole from Morgan Stanley coming to talk to us about categories and classes. And if you've actually built ontologies and taxonomies, you've run into a problem like this. We're going to get some insights about how they've solved this at Morgan Stanley.
I don't know if we've completely solved it, but I think this actually, it was really interesting to listen to Heather's talk, because I think this segues nicely into
I think this is the answer of a question I wanted to ask Heather. So
okay, we'll see. So yeah, so I joined Morgan Stanley a couple of years ago, and when I got there, it turns out they were using the GIST upper ontology, which has this, or the GIST upper ontology, which has this concept in it called a category, which we'll get into in a moment. And it turns out to be, to my mind, like a really, really key concept for doing ontology development for a number of reasons that I'll get into. So today I just want to first talk about, what are these things called categories and why are they useful? There's 2 ways in which they're useful. They're useful for us for handling like uncertain, imprecise data or models. They're useful for elicitation, so in that vein of the underdefined and precise. But I also want to talk about one other thing. They actually turn out to be quite useful for wringing some more expressiveness out of a first order logic, which I think is actually kind of a key thing. So I know I don't have too much time, so I'm going to try to hit those first points. And if we have enough time, I'll talk about some category gotchas where you shouldn't be using categories, or we've used them badly, or bad things that we've done in the past. So, okay, so as I said, categories. This is a concept that exists in the GIST upper ontology. Maybe other people have them as well, but they were sort of new to me. But essentially, the idea of a category is it's a type, except it's first order. It's a named individual that exists in our first order realm, but it's used to represent types of things. And so what does GIST say about it? It's a concept or label used to categorize other instances, and things can be thought of as types are usually categories. So it's kind of, think of it as a bucket, right? Like it's not unlike a class, except it's in our first order world. And then I think one of the key thing I want to note here, just also because it'll make the slides a little bit clearer, we take our categories and we define what we call a C box, which is our category box. So we keep them separate from our classes and our properties, but we have a specific place in our ontology space where we capture our categories. And in the slides here, I'm going to use C box as the namespace for the category space, and T box for the typical ontology space. And so as I said, they're types, but we treat them formally in our logic. We treat them as like first order objects, like computers and baseball players and things like that. And in some cases, they play a couple different roles for us. Sometimes they're just stand-ins for saying this thing, it's a type, but we really don't have too much to say about it. So we're just going to call it a category. It's just going to sit there. And eventually, maybe we're going to define it as a class, and we'll give it the necessary and sufficient conditions for membership or what have you. But sometimes it's a promissory note. Sometimes it just kind of just exists and hangs out there just as a category. But the one thing it does, it allows us to kind of keep our ontology a little more lightweight as well, right? There may be things that we say we don't really have, and I think this is something that Heather was talking about this morning as well, or the earlier talk, where sometimes the ontology, we want to say a whole lot of stuff and axiomatize a class, but sometimes the category isn't necessarily that important, except for saying stuff gets categorized into it. So there's 2 use cases that we've used these things for some time. The one, a typical use case is, we're ingesting data from some relational source, and let's say we're pulling in car data, right? And we're pulling in, and it has a field in there for body type, and it's there's like I don't know, sedan or station wagon or a compact or sports car, and we say, well, look, we don't know what distinguishes a sedan from a sports car. We're not really sure. Does anything depend on that? No, not really. So we're just going to create a bunch of categories. We're going to just say, here's all these categories, and we're just going to create this list of things. Essentially, we might create a hierarchy, but we're saying we're not going to create classes because I don't know what how to distinguish a sports car from a sedan. If somebody wants to do that later, we will. But for now, we're just going to put them in our category box. And the other kind of typical use case is if you have a tagging system. You're pulling in some data. Like we pull in we have like jive articles with tags on it, and we'll sometimes just call those tags categories because people they're just saying, well, this is a topic or something like that. But we'll use tags for those sorts of things. So basically, situations we say, well, we don't really have that much to say about to formalize this concept, but we may want to do it later. Keeps our ontology a little lighter. It keeps the ontology focused on the actual questions that we want to answer. But the other thing I want to talk about, where I think we've kind of come up with something sort of novel, and this also gets back to something Heather was talking about this morning, but where is usefully use of taxonomy, and I think that this kind of corresponds with that. At Morgan Stanley, we have all kinds of different typologies that evolve, right? There's financial instruments, regulatory, categories that exist. We're in the middle now of like information sensitivity, all kinds of new ways to classify, the way that documents have to be maintained and sensitive, protected from being spread around, and that kind of thing. Any people working ontologists here knows that can be a real pain, right? So you have to, if we just got a new financial instrument came in or something like that, you have to open up a JIRA. They have to extend the class hierarchy. So what we've kind of stumbled upon is to say, well, let's use this approach to classes or to categories, and let's just put those categories in SCOS, mostly because SCOS has some nice UI tools that are very accessible to business users, but also the taxonomy management tool we have also has nice workflows, right? So we said we can take this task of maintaining these typologies and let our business users or SMEs do that, because we'll just create this nice SCOS interface where they can kind of come in, they can extend the taxonomy, and then later, if an ontologist wants to bite into those categories and say we're going to turn these into classes with axioms or what have you, they can do that. But this gives us a way to get our categories, or the key things for doing the sorting, created quickly without having to have a long discussion with some PhD in philosophy who's going to want to understand all this necessary and sufficient conditions and things like that. So what we do, we create these. We have this. You can see here. This is an actual view of our category classes, and there's things in there like building type, business unit type, container types, email types, entitlements, things like that, right? Just kind of, some of these are more or less flat, some of them have a little bit of structure to them. But again, these are legitimate categories, but they're not something that we're going to say an awful lot about. In our taxonomy management tool, somebody wants to come in and say, I want to extend this, I need to have a new business unit type. We can create a task so that it goes into workflow management. They can kind of come in, create a new business unit type. They say, we're missing marketing. So they come in, add a marketing concept. And I'm going to make a note here. The one thing that we do, we use SCOS completely, except we have this distinction between a named individual and a class. So we extend the SCOS concept to include class and individual, because what we also still need to do is to have classes of categories and then categories themselves. So the named individuals are the actual categories. The classes are classes of categories. So, and the point here now is a business user can kind of come in, name this thing, add alt labels. We get it ingested into our ontology. It goes to a taxonomy manager who can view it, make sure we follow all the naming conventions, get it extended. Similarly, let's say we want to add a new class of categories. We say, well, you've got a bunch of business unit types, but there's some unique to the pharmaceutical business that we need to represent. So we now create a class of categories called pharmaceutical business unit type. We can then extend the ontology with that, and let's say research and development is more or less unique to pharmaceuticals. So now we have a new class here, a new category here under a subclass of category. So this essentially is the point here is this is a lightweight tool that our business users can use. Now we get this quickly into our knowledge graph. We can start using it for ingesting data, for doing tagging, etc. They can add their alt labels, all the kind of stuff that an SME can do that we don't have to we don't have to talk to an ontologist to ingest this stuff. So in the interest of time, I'm not going to go through this, but we actually, we've defined this whole mapping pattern to move back and forth from SCOS into our OWL ontology. And you can, if I think these slides will be available later, you can dive into that. But we basically said a concept scheme that is of type class that a concept scheme falls underneath, is a subclass of category, but we can also create further categories underneath the concept scheme. They're tagged as classes, and we can capture subcategory. But all this is done with just the broader narrower, and we're just relying on the fact that we've got individuals and classes. So this is our translation mechanism. We take our data, we run a Sparkle query, we take our data, and then once when we release our ontology, we also release a new version of the CBox that contains all the updates that have been made by the SMEs. So the workflow looks like this. A business SME comes in, extends the SCOS model, throws in a new category, maybe a new financial instrument or what have you. Somebody, taxonomy manager, validates it in SCOS, goes through that workflow management. Those changes get put in the ontology development for immediate release, right? We can now take those things and start using them, putting them into the knowledge graph, tagging things with it, what have you. But then on the side, I guess I should be using the cursor to point this. On the right side here, the ontologist can now be taking those categories and saying, well, wait, you've just created an important new type of interest rate swap. This is something important that we can capture some important information about that. And they may want to create classes corresponding to that. So then in a subsequent release, we can actually get, class versions of some of those categories as appropriate or necessary. But so the point of this is it's yet another way to break what I always call the ontologist bottleneck, right? One of the big problems with getting knowledge into a knowledge graph is getting the ontologist to agree, to understand the concepts, to get the stuff into the graph. So it's a way to partially get around that a little bit. We can get some of this data in the graph, some of the key things like the labels, the alt labels, just simple ways to categorize the material. And then we can have another parallel workflow, which the ontologist can note it and extend the class hierarchy as they believe appropriate. So I like to think this is a good step forward in doing more agile ontology development. Okay, so let me, so we've just kind of gone over, as I said, like using categories to capture stuff that's underdefined and imprecise. But I want to then move now to talk about how we can use it to be somewhat more expressive. But before I do that, I want to just talk a little bit about some of the key taxonomy concepts. So the stuff that's in GIST that we basically leveraged to use is, there's this concept called category, which is just a subclass of thing, and it's a type class. Categorized by, the easiest way to think of that is just, it's an analog of RDF type, except it's working in the first, with named individuals. But it basically says, it points a named individual to a category. It says, essentially you can think of it means this thing is in this category. The other concept has super category. That's where we take two categories, and again, that's sort of the analog of subclass of. We say this thing is, so everything in the upper category is everything in the lower category is also contained in the super category. We've made a couple modifications that to consider here. We have this other notion called corresponding class, which is well, it's an annotation property, but you can think of it as syntactic sugar for defining a class that corresponds with a particular category. So the class, the corresponding class is the class that's all and only the things that are categorized by that category. We also have a notion of category subtype, which is kind of a quick way. It's also an annotation property, but it kind of says, these are the kinds of things that would fall into this category, because it's another way to kind of express the meaning of it, to say, there's an example coming up where we talk about bear. Well, you may want to say, well, the kinds of things that fall into the bear category are going to be animals rather than like pictures or something like that, right? So we have that. And then the other thing another way to extend this is, there's no reason we have to stop with just categories. We can go up to second order categories, et cetera. So I'm going to talk quickly about a short use case where we could use this, but we can also introduce the notion of category categorized by. We can categorize our categories. Our second order category, we're going to do the same trick. The second order categories are just first order individuals, but we just use them in a special way. Okay, so as I said, the key thing here we're doing is to ring the further expressiveness is, this takes an old trick for bringing more expressiveness from a first order logic, right? First order logic is highly desired because of its various features. But what we can kind of do with these categories is turn that first logic multi-sorted, right? So we're basically kind of carving up our domain of named individuals. We're saying, here's our traditional named individuals. We're going to have one more set, which is our categories. And if we want to, we can have another one that's our second order categories, etc. And I just want to, so I'm going to just talk briefly here about how this extends the expressiveness of the ontology. So as I said, we first talked about how we can slide things into the ontology without doing much classification, but it solves a lot of key problems. So here's this old problem. If anybody's read Dean's book, they're familiar with this. This is the problem is Mike is an instance of Homo sapien. So I want to say that I'm an instance of a particular class. But that class is actually a species, right? Well, we can't really do that in OWL, right? We can't say that we can't have a class being an instance of something else. So categories do give us a way to do that, though, without resorting to punning, right? And what we do with that is, again, here, we can define a subclass of category, call it, let's say, animal classification type. Maybe there's a prettier name for it. And we can define subclasses of that, which are, class, family, genus, kingdom, order, et cetera, et cetera. These are all classes of categories. Now we can go in here and we can say, for example, animal is an instance of kingdom. And I'm not going to try to track how these things all match up, but these things are then, each of these categories here are instances of some object in our category hierarchy. So what happens with this is, and we can also, while we do this, we can also define the corresponding subclass hierarchy corresponding to that, so we can get all our clever inferences about where this thing falls, etc. So we can have the categories, corresponding set of classes, and now I can do things like say that Mike is categorized by Homo sapien. And again, if we have the corresponding class for that, we can infer that I'm of type Homo sapien. But now we notice what we've been able to do. We can now say that Homo sapien is Homo sapien is subclass of Homo, and I can also say that Homo sapien is of type species, right? Because it falls into that category class. So now we kind of have an indirect way, but we've got a way now without resorting to punning of saying, okay, this thing is actually a species, and we can kind of get around that. So we get this kind of second order utility out of this. Now this is actually, I pulled that example because I think it's a traditional one in the space, but it's actually very practical for us, right? If we start looking at, let's say, industry classification, if I want to say, let's think of the class oil and gas companies, right? That's an industry, right? We want to say that class is an industry. So that class is an instance of industry. And another example that always bothers me, I want to say that if Apple issues a stock, that's a financial instrument, right? That's how people talk about it in banking. They say that thing is a financial instrument. But I also want to say that the particular Apple stock that I hold seems to be an instance of that class, right? So there's different places within the finance realm that we want to be able to leverage this. So we can do this for, I'm going to just jump right over here to this thing here. So let's just talk about the industry classification thing now. If I've got Ford Motor Company in my data set, I can now say it's categorized by this automobile manufacturer category, and that's a subcategory of automobile company. And those things, those two categories are now instances of industry and sub-industry, and those are both subclasses of a GICS category. And I can still say that the corresponding class to each of these categories is automobile manufacturer, automobile company, and I put Ford Motor Company, then again, we can infer that that's a type automobile manufacturer, and Ford is then an instance of automobile company as well. Okay. Let's see, I don't have too much time, so I don't want to spend. I'm going to just jump. There's another thing that we can talk about. I'm kind of enamored with the whole onto-clean vocabulary, and I think this gives us a nice way to handle that, but I'm going to skip over that because we don't have too much time. But but another kind of key thing I think that I often miss in a first order logic is, let's take a taxonomy of cars, right? If I have a taxonomy of vehicle types, we actually want to, it's actually can be quite useful to parameterize that list, right? I want to be able to say, some of these car categories are categorizations by the maker, some of them are by style, some of them are by engine type. And again, I can get this effect if I'm using categories, because now I can say this thing is just this vehicle by engine type, it's just a first order class. It's a class containing categories, but it's just a first order class. So those things underneath it become categories. So I get that kind of additional expressiveness with respect to, to making my class types more expressive, so that they're kind of acting like second order classes, but they're, we shuffle them in by using this first order category trick. And then, so for vehicle, it's just an individual in this case, so we can make it an instance of vehicle by maker. And I think the one other thing that I want to stress here that I think is very useful, and I encourage people to use it more regularly, is it also gives us the ability to kind of create type level predicates or de facto type level predicates. And this is also very useful if we want to elicit information from SMEs and things like that. This is kind of thing that we often want to do, is to say, describe for me this particular business process. And all of our regular OWL properties are operating on the named individual level. Once we create these categories, I can actually make type level declarations. If I want to say, for example, that, what type of person performs this type of job, now I can say this kind of thing, right? I can say trading is a job type performed by trader, where trading and trader are both categories. And this really, it's essentially a way of creating a rule, right? We can turn this into a constraint now that says oh, if somebody's doing a trading, they should be a trader. But this is something we can now have SMEs that we can elicit from them. We don't have to write we get that kind of for free. Similarly, event type is sub-process type. I want to say every instance of baking bread involves, mixing flour or something like that. We can make those type level declarations, and again, make their ontology development far more straightforward. I think that's, yeah. So one more thing, and then I'll open up to questions. The one thing I really want to emphasize, because this is an error I sometimes see. If we have there is this tendency sometimes when we create these things, if we have like perform by, we have to be really careful with our scoping, because we've turned this thing into, we've made it multi-sorted. So if we have a first order predicate that's supposed to link, let's say, events and people or something like that, that's performed by, there is this tendency to say, oh, okay, I'm going to actually say there's this job category, and it's performed by Mike, and that's the kind of mixing. So that this actually places kind of a constraint on your domain or ranges of your first order predicates. You want to actually make sure that you don't extend the domain to allow to mix these categories with your other named individuals. So, and if you look in the GIST ontology, they actually allow for this as well. They have these concepts of prevents and avoids. Those are category level predicates that they use in there. So, but I will stop there. I've got a whole bunch more slides, but this is a good place to pause. So, yeah.
Thank you, Mike. To see someone take a pattern that I wrote about in my book and really carry it a lot farther and turn it into sort of the basis of, well, you've basically done second order type theory and built it into OWL. So that's pretty cool. Any questions from the room? We have a couple here. Yeah, Chip.
Hi, Mike. Great talk. So at Morgan Stanley, how frequently have you actually had your business analysts come in and create new categories, and how frequently do those end up getting lifted to become classes?
So most of the categories that we have now are things like of the sort that you saw, where so I think so I don't think, well, for this it's pretty new. We're just using it in our space right now. So it's I won't say we have tons of data on this, but we do have the system set up, but although the people who are using it now are people who tend to be fairly well versed in taxonomy management in the first place. So I don't have clear results. But the other thing is, in fact, I don't think we have situations where we said, oh, this thing should be a class, we're going to take it out and extend it. But that's partly because the list is fairly constrained. Like I said, I can imagine it if we're doing financial instruments or something like that, where it's like, hey, yeah, this thing we need to blow a class out for that. So it's mostly, so that workflow is fairly notional at this point.
So the question from the chat that I find kind of interesting says, are you using Protege? How do you manage visualization? Well, the Protege question is sort of a red herring, but how do you visualize this since you've kind of got a duplication between the category and class?
Yeah, that's a good question, because in Protege it doesn't visualize very nicely, right? Because all those things are just instances. So you've got these categories, and then you categorize by. So that's where the taxonomy manager, it does give you a nice view of that. But yeah, visualization is in Protege that's a problem with lots of things.
I'll take another one. Wow. I'm going to start here. I think you were the first with your hand up.
So I have a question about this last slide. So we've been using this pattern in one of our ontologies, and this about how you should use different predicates. This is somewhere we get a lot of pushback. Like, say, the predicate invented by, people want to kind of use that to say most things were invented by a named person, but a few things were invented by, say, things like ancient Greeks
or IBM.
So,
but I'm not sure if you say ancient Greeks. I think it depends what the claim is. If you're saying ancient Greeks is like an agent, that like some kind of corporate agent, maybe it's okay. But I think that's probably a good example where you want to say it was somebody who fell into this category that invented it, rather than
No, don't do that. But I feel like I don't have a very strong argument apart from just instinct. So do you have like more kind of strong?
No, I don't, other than don't do that. I don't know. But that's the kind of thing where as an ontologist, you can define that, right? We can create constraints and say, well, this thing violates that, or you can say, well, we are going to leave it open-ended. It could be. I mean, the thing about, if we talk about ancient Greeks, so like I said, it's a little bit. It's not clear whether that's acting as a category or a group of people, right? Which is slightly different, I guess. So, but yeah.
We're officially on break. Because it's a break, we don't have a hard stop like we did for all the other talks. So following on to that, there's a question here from the chat. What is the advantage of categories over just punning? I don't know. Answer that, but I want to hear yours.
I'm not sure if it's not intuitively clear. I guess the key problem I think with punning is that we're treating the same thing. We're making contradictory claims about the same object, right? We're playing a trick. But
that is, it's really poor software engineering. Name me any other language where you can do it. And the answer is, you can't even speak a pun in Java. Right. There's any way to do it because it's a category error. It's literally a category error. Anyway, we can move with more questions here. That hand went up nice and fast. And if you want to go to break, no one's going to be offended that you decide to go out and get coffee, because we are officially on break now.
I'm just curious to know, how like when in downstream applications, the way you treat classes is very different than you treat instances mostly. So if you're doing this thing that you have something as a category instance, and then eventually it's going to turn into a class, how do you foresee this affecting your downstream applications and making those changes and notifying all those users?
That's funny. Is Mark Wallace here? Because he and I were just having this discussion earlier. I'm not sure. I mean, that's always a problem with them. I mean, it's like I said. I think as I said, I think it makes ontology develop more agile. But that is a recurring problem, right? Like if you create an ontology and you don't have it perfect the first time, you're going to have to come back and you're going to have to update people's queries. And so so there's not a simple answer, but I don't.
I want to try answering this a different way, because it seems to me that that's one of the strengths of this pattern. So if you have something in your A box and you write a query about this in your A box, and you're just treating it as an A box thing, you put a C box thing there, use the thing I call the class instance mirror pattern to link it in. That's the pattern you had on your slide. another query could speak about the class. You've actually, by not punning, you've forced one query writer to talk in the class language, the other query writer to talk in the ABOX language. And when you say, gee, I want to do classes, I want to get, it seems like there isn't actually any migration. You've done both things at once. And so you've actually got rid of the need to migrate. If you did punning, you said, oh, I'm going to treat this as an instance. Let's write all these queries like instances. Oh, no, I changed my mind. And suddenly all the queries, wait a minute, I wasn't expecting that to be a class. That my queries are no longer provable, or maybe they're even wrong. So it seems to me that your pattern is way more robust in this scenario. And it's not perfect. You're right. I mean, obviously, there's still migration issues, but it seems like that's another argument for why not to pun and why instead to do this. Because that's how I see it. Okay. Yeah. I was wondering why I hadn't heard from you.
Just a short comment about punning. The reason not to use punning, in my experience, is you're either going to confuse yourself. And if you don't confuse yourself, you're going to confuse someone else who's trying to use what you did. So, and the reason it's all confusing is what Dean said, that nobody does it anywhere except in O.
Yeah, here. All right. I think with that, and since we're now well into break time, let's thank Mike for his talk and everybody back. I think it's in half an hour that the panel starts. It's in the right after the break. So we'll see you back at the panel. Sure. I'm watching you.